Hello, in this video I'm going to solve this checkpoint problem. Let G be a group and let A and B belong to G. If X belongs to G satisfies these equations, you see XA x to the third equals BX and X squared A equals to XA inverse. Determine X in terms of A and B. Pause the video at this point and give it a try. Okay, so let us now solve this problem. So here we're not you are supposed to find X in terms of A and B. A and B are group elements. We want to, and we know for this group element this works, and I want to find X in terms of A and B. You have to be careful. I am not allowed to write this as x to the third, a to the third, x to the third, because if you remember during the lesson, I just told you that if you have ab to the nth, it is not always the case that this becomes a to the nth, b to the nth, unless we know that a and b commute. And nothing has told us in this problem that a and x should commute. So we cannot take this commutativity for granted here. So if that is not possible, there is only one way to start here. So what I can do, I have to use the definition of the third power. So what I will do here, xa x to power 3 means xax times xax times xax. And on the right hand side, I have bx, copy and paste it for the time being. But because you know that in any group we have associativity, in principle it means that I am not worried about where to put these pairs of brackets. But I have to be careful about I am not allowed to swap these things, so because we don't know commutativity here for granted. So what I will do, so in principle, if you want to write it a little bit precisely, you can write it as ax and then put a pair of brackets between these two x. But I would recommend you to just remove all pairs of brackets. Then you will have this scenario. And I copy and paste the right side. And then you see what happens here. This gives you x squared. And this will also give you x squared. So if I simplify it, this becomes xa x squared a, x squared a, and x equals to bx. But then you see that you know something about this combination x squared a that appears here. So far, so good. But we also have a rule that we learned during the lesson, a socks and shoes theorem. So if I have this, I have to change the order. If I want to take the inverse of a product, I can take individual inverses, but I have to change the order. So this means that if I open this up, this becomes A inverse X inverse. So this means that X squared A is equal to A inverse X inverse according to this problem. So what I do, I will actually replace this with A inverse X inverse. I also replace this with A inverse X inverse. Okay? So let me put everything in place. So I copy and paste XA. Instead of X squared A, I put A inverse X inverse. Instead of this X squared A, I put A inverse X inverse. And then I copy and paste this X, and then I have BX. And now what you see is that these two becomes the identity element, and these two also becomes the identity element. So this I can just drop it, then I have X. I don't need to write E because E is identity. Then I have X inverse here, I have A inverse here, and this one is identity, I don't need to write it, and it becomes BX. And then fortunately these two become E again. So E times A inverse becomes A inverse. So what I will have is that A inverse is equal to, copy, paste the right side, BX. but I want to find x in terms of a and b, so I have to isolate my x to get rid of this one. So because b is sitting on the right side, so I will multiply this by b inverse from the right side. So this becomes b inverse a inverse. The b inverse that I multiply here because of associativity, it becomes e and it gives me x. So that's good enough. So x is written. Of course, if you really strictly want to write it in terms of b, it's better to write it as ab inverse, which is exactly that expression. So this is the solution to this problem. We write x in terms of a and b. Okay, I hope that the video was useful. Until the next video, be safe and goodbye. Thank you.